A very good morning to one and all. I welcome you all for day 3 webinar being conducted by Bharadasan University Entrepreneurship, Innovation and Career Hub. Myself, Tyagarajan, working as Assistant Professor in Department of Computer Science, Central University of Tamil Nadu. Today, topic of discussion is on IoT clouds, analytics, and visualization. This is the webinar overview. Day 1, we had a deliberate discussion on introduction to IoT with some examples. Day 2, we had discussion on IoT architecture. And day 3, today we're going to discuss in detail about IoT clouds, analytics, visualization. Day 4, we're going to elaborate on networking and Internet of Things. Day 5, the avenues, the open problems in Internet of Things will be discussed. Before we proceed into the today's topic, we'll just have a small recap of what we discussed on the day 2 webinar, that is on IoT architecture. We started with what is an embedded system, what are the characteristics of embedded system, how the embedded system is differentiated from the real-time system, what are the constraints that these embedding systems are facing, and within that limits how they are functioning. We discussed in detail about architecture of embedded system, and it contains 3 main components, that is sensors, microcontroller, and actuators. And again, the microcontroller is classified as 3 main parts. The brain of the embedded system is classified into 3 main parts. It is nothing but microcontroller by itself, FPGA, and IP core. We discussed in detail about all of these components of embedded architecture. We discussed what are the different kinds of sensors that is available. We discussed around 18 sensors that is available. There are many sensors available. After that, we have chosen only 18, and we had a discussion on the 18 sensors which is available. Similarly, we discussed about some architecture, and we discussed what are the functionality of the architecture also. Then we compared what are the different platforms that enable this IoT project to be functional. We discussed around some 9 to 10 platforms. And among that, Raspberry Pi and Arduino are the mostly frequently used. So we discussed in detail extensively on the Raspberry Pi and Arduino, where to use Arduino, where to use Raspberry Pi, what are the pros and cons of Raspberry Pi. And we also compared this Raspberry Pi and Arduino on some set of features. So with this, we concluded the day 2 webinar. And with that basics, we are going to discuss today on IoT, analytics, cloud, and visualization. So the picture in front of you it has the details about how much of data we are generating in a single minute. That in 60 seconds, this slide shows how much of data we are pumping into the world. For example, in 1 minute, that is 60 seconds, 320 plus new Twitter account has been created, 100 plus new LinkedIn account has been created, 1 article is published, this research article, and 6,600 plus medias are shared in the Flickr, and 1,700 Firefox open source web browser is being downloaded. And I see in Google, can you guess in a single minute how many search queries are being served in the internet? It is around 7 lakh search queries has been thrown to the Google in 1 minute, and 168 million emails are being sent in 1 minute, and 600 plus new videos are being uploaded in the YouTube, and 13,000 plus iPhones apps are being downloaded, 1,600 plus scripts have been read, and 13,000 plus media has been posted in the Pandora, and 3,70,000 plus minutes voice call or video call has been made in the Skype. So these are some of the statistics which shares how much data we are generating in a minute. Imagine if in a minute we are going to generate these kinds of data, and imagine per hour, per day, per week, per month, and per year. Imagine how this data will be huge. So with this data, what we're really going to do, whether we're going to get something out of this data, or whether this data is of no use, it has been generated and it is of no use, whether we are not going to infer anything from these data, that's a question. Hold on with that question for some time. Again, apart from these things which is being generated in the internet, these are the data which is being generated by the internet. And to this data, which is generated in billions and trillions, this IoT to its level also is contributing the data. For example, the picture which is shown here, it says how the peoples are connected to the things and generate the data. In the figure, you can see a person who is running and in which he has a sensor. One is that ECG sensor and another is nothing but the motion sensor. Motion sensor will be attached to the both legs and hands. So whenever he moves, that motions will be captured and the ECG sensors will capture the heartbeats rate and it will be directly communicating. For example, in the slide it is shown, the motion sensor is calculating or sensing the motion, how many times he is moving his hand and how fast, what is the velocity he is moving. And the ECG sensor continuously checks his heartbeat, and that has been developed as an application. And then through internet, is going to the hospital, his hospital. Imagine in a day how many times a person will move his hand, and the heartbeats continuously generates the data, non-stop. Stops, of course, will die. So imagine that how many data will be generated, how much of data will be generated per day. All this data has to be collected and stored somewhere. So again, these contributes to the data which is shown in the previous slide. So nowadays, people communicating with the sensors. So there was people connected to things. Again, we are generating data here. And to add along with this, we also generate data and things will communicate among themselves by sharing the data. So these are some of the examples in which the things communicate among themselves. And again, they also contribute to their share to the data. Humans being contributing to the data. Apart from this, now slowly with the introduction of IoT, things also will get connected. I said, right? Yeah, IoT device is nothing but a device which has a computation intelligence along with the network connectivity. Unless otherwise network connectivity is there in the device, we cannot call it as an IoT device. Since we have network connectivity in a device, which will enable the device to communicate with other device in the network or in another network. Again, this communication will take place through the exchange of information in the form of a data. So again, when device start communicating to their part, they will also contribute to the data world as a piece of their share. For example, in IoT architecture, if you suppose install a sensor, the soil last time in the second day 2 webinar we have seen rain sensor, which will sense the moisture in the soil and accordingly it will supply the water. Farmer need not go to the farm at night or the daytime to switch on the motor. No. When the sensor detects the moisture level is low than the threshold, it itself initiate the action and it will pump the water from the well. So now see the device communicate among themselves, how the sensor, the IoT device will communicate with the motor. Again, that will communication will take place to the internet and it will share the information from the sensor to the motor and the motor will act upon the instruction given by the sensor. So device communicate among themselves. And one such example is that smart retail. You know that there is a trolley in each and every supermarket. And whenever we go through different section of supermarket and whatever things we decide to buy, though we are not intended, simply because of seeing those things, we'll put that in the trolley. And after putting that in the trolley, there will be a long queue in the billing section. Again, it depends on what day you're going. If it is on weekend, definitely you're going to wait for half an hour. If you're lucky enough, you can come out very quickly. But then this IoT enabled trolley will not make you to wait in the billing section. What does it do? As soon as you put your product in the trolley, US will start calculating. So you can directly walk onto the cash counter and you press the complete button in the trolley, it will throw the bill. So you need not wait or you need not show each and every items and the barcode will be to the scanner and then the bill will be calculated at the counter. Those kind of time wastage will not be there. We have a small trolley in the shopping mall, your job is done very smoothly, except that you have to stand in the queue and pay the money for your items. Again, now see here, things started communicating. The glossary items which you put in the trolley will be able to communicate with the trolley through RFID or barcode or whatever the mechanisms you have. This communication between the things, again, they contribute the share to the data world. And similarly, smart home appliances can calculate, communicate the data among themselves for making the application smart and human life much sophisticated. Similarly, we can have this IoT device even on the pet to track them where they are. And even in embedded systems, we can have this IoT device that we've seen in the last class. So all these devices also putting the share to the data world apart from the humans. Really, what we're going to do with this data again is a big question mark. We'll see. To the share, IoT also is contributing data. Already it is there in the millions and trillions, and IoT also contribute to the share of billions and trillions in the data world. And with that, what are you going to do? Whether something is going to derive useful from this data, it's a question mark. So the data grows big and big and big, and we call that it as a big data. Big data, not in the sense, big data in the sense, data is really huge, really huge. So there are four V's when you talk about the data, big data that we have to discuss for sure. The four V's are volume, variety, velocity, and veracity. So these are the four characteristics of the big data. The volume, in the sense, how much you have the data. So generally, big data is how big is the big data? That's a frequently asked question when you read about big data in the book or in the internet. So it will be a huge size. So at 2020, the estimated data size will be around 40 zettabytes. Zettabyte is nothing but 10 to the power 21 bytes. Imagine 10 to the power 21 bytes into 40. That's much of data is expected to be there in 2020, and it is estimated around 2.5 quintillion bits will be there in next 5 years. So lots of data. I said per minute you are going to generate a lot of data. Imagine in the coming 5 years, imagine the rate of the growth. So nowadays you cannot see people without a mobile. Apart from kindergarten students, everyone has a mobile. And again, that the mobile, if you use, then definitely to have internet connectivity. That's a smart device. Imagine the data which you're going to generate. So you cannot expect the rate at which the data is growing and being generated per minute. That's a small statistic I was shown. It is beyond your imagination. The data are being generated in a day around the world. So volume of the data is really big. So for sample, it said that in 2020 it will be 40 zettabyte, and in next 5 years it is estimated as 2.5 quintillion bytes. Variety of data. The next characteristic of the big data is variety. Variety in the sense, we will not generate only single type of data, the world, because we are using many kind of smart device. The data variety in which is being pumped out to the world, it's a huge variety. We have bits, we have Facebook posts, we have YouTube videos is being uploaded, we have photos which is uploaded in the Flickr. We have information from the IoT device. We have information from variety of sensors, right from irrigation to ECG sensors. We have emails being sent out. We have data sent out from the smartwatches. If you see, we have all kinds of media data, all kinds of text data, which is being pumped out to the real world in a day. So here the big data contains all sorts of data. Name any type of information, everything will be there. So that is the second characteristics of the big data. The third characteristic is nothing but velocity. Velocity says how much data is being pumped out at a given point of time to the big data world. That's called velocity, analyzing the streaming data. And the fourth characteristic is that veracity of the data. Veracity of the data, it deals about uncertainty of the data. So these are the four main characteristics of the big data. Next is a very important slide which says how this big data is different from the traditional data management system. In the traditional data management system, the data which you're going to store is structured and it is related among themselves. Whereas in the big data, the data which you have is totally unstructured. And in traditional database, DBMS, if you want to scale up the infrastructure in the sense the storage, then it costs much. whereas the scalability in big data database management system cost is very low actually. And third parameter is that we have well-defined schemas and models in the traditional database management system, which help us to get quick inference from the data to queries. Whereas in big data, the data are very complex, and hence we need some complex analytics mechanism to get some meaningful insight out of it. In generally traditional DBMS is managed in a single process. You can store, you can able to have a quick inference. Whereas in the big data, you need the distributed processing. The data is split among different processes and all has to work on the same task to get some meaningful insight from the data. Because of the size, we need the distributed processing. Some examples of this traditional DBMS are nothing but Microsoft Server, MySQL, all comes under this traditional, and the big data we have MongoDB, Cassandra, NoSQL. In general, we cannot store the big data in the normal traditional database. That's what the essence of the slide. We need a specialized data management system to store the big data. Now, we have seen in the first slide, per minute in the internet, how much is data is being generated, and slowly these IoT-enabled devices also contributing to the data, apart from the data which is being generated by the internet. According to the International Data Corporation, it's a center in, it's a headquarters of IDCs in US, which mainly works on this predictive analysis for the market purposes. It predicts this IoT, that is Internet of Things, will generate about 79.4 zettabytes of data in 2025. Already we discussed zettabyte is nothing but 10 to the power 21 bytes. Imagine 79.4 into 10 to the power 21 bytes of data will be generated in 2015. This is what it is estimated. It also estimated that the device, if you take the number of IoT device throughout the world, it will be around 41.6 billion. Again, it says, these data says that the usage of this IoT will drastically go in the next 5 years. And it also says the growth rate of these IoT devices, it will grow at 28.7% from 2018 to 2025. This slide mainly talks how this IoT contributes to the big data and how that growth will be in the forthcoming years. So now this slide talks more about how this IoT, big data, and cloud are related. You know, for any data analytics, the foundation is data. We need to have some data to do the analytics. In other sense, the data has to be collected. Our data has to be gathered. And gathering the data itself is a big task. And with the help of IoT, thanks to IoT and the devices, which helps to gather the data, which helps IoT device will generate the data. So this will be done by the IoT-enabled devices, and we will have the data. And in turn, IoT data will also contribute to the data which is generated by the internet. So data generated by the internet plus the data generated by the IoT will contribute to the big data. And these data need to be analyzed to get some business insights. For that, we need to do analytics. And to do the analytics, we need to place the big data somewhere. See, data is collected by the IoT device. Data is collected, generated by the IoT devices. And these collected data need to be stored somewhere to do the analytics. Otherwise, we cannot do analytics. We need to keep the data somewhere. And cloud is a place where we can keep the data. I think I'm slowly connecting these three dimensions: IoT, big data, and the cloud. IoT contributes to the big data, and the big data, which is nothing but the data generated by the internet, as well as the data generated by the IoT devices, generally called the big data. And this big data need to be stored somewhere. We need to store it. That is stored in the cloud. Otherwise, you can say cloud is a place where we can store the big data. So if I say analogously, we can map IoT as a king, big data as a queen, and cloud as a palace. You may ask, why am I mapping IoT as a king? King is a real breadwinner for the family. Breadwinner means he will go out and he will search for the food. and he will collect some food items. Here, IoT is the one who collects the data. King is the one who collects the food, and IoT is the one which will collect the data. Since IoT devices is collecting the data, I am mapping that IoT as a king. And the big data, I am mapping that as a queen. Because whatever data given by the IoT and the data which is generated by the internet put together, it will organize it with themselves. Put together, it will have. Put together, it will assemble. It will keep the data. That's why I mapped big data as a queen. What does generally the queen do is that whatever the king is bringing from the war, he will be giving to the queen, and the queen will preserve it. Here, the IoT generates the data and it will contribute to the big data, and the big data keeps themselves the data, which is generated by the internet as well as it is generated by the IoT devices. The both king and the queen lives in the palace. That's why I mapped cloud as a palace, because the big data it resides inside the cloud. The big data is nothing but the IoT data as well as the data generated by the internet. So both king and queen will live in the palace. Similarly, the IoT data, which is generated by the IoT devices, and the internet data, which is contributing to the big data, both will be placed inside the cloud. That's why I mapped IoT as a king, which is nothing but it is generating the data, and the big data as a queen, which is assembling all this data put together as a bundle, and the cloud is a palace. Palace is the place where the king and queen live. Here, the king I mean IoT, and the queen I mean big data. So I establish a small thread between this IoT, big data, and the cloud using this example. Next, I also try to portray that connection between the IoT, big data, and the cloud through this diagram. See, as I say, the data is being generated by the IoT devices. Hence, I call this IoT as a king. Here, if you see the first component, that thing or a device is generating the data. And this generated data through the network, whether it is wired or wireless, it will transmit to the cloud. See, the data is generated through the wireless devices, it's transmitted to the gateway, and it is stored in the cloud. This data stored in the cloud is again the big data, because it is gathering the data from IoT devices. And apart from that, it will have many data generated by the internet itself. So both IoT generated data and the big data will be residing in the cloud. Hence, I called cloud as a palace, because it stores the data. Both big data and IoT data is stored there. So I say cloud as a palace. And I say big data as a queen because it assembles all the data. It assembles the data generated by the internet, and it also assembles the data generated by the IoT devices. Hence, that is the job of a queen, right? Queen assembles every members in the family, and it will preserve whatever king have from the war. So the preservingness will be from the big data. That's why I mapped big data as a queen. So coming back to this slide, the data generated by the IoT devices will be passed to the wireless network and it will be stored in the cloud. Once the data is stored in the cloud, we need to do some process to get the meaningful interface. Here the process nothing but I mean analytics. You need to do some analytics to get some meaningful interface. Again, we need to have an analytics tool which will have a good user interface. This is a slide which clearly establishes the diagram how these IoT devices, cloud, the big data are connected. Again, I will repeat, IoT is nothing but the king, which is generating the data. Big data is nothing but the queen, which assembles the data generated by the internet as well as the data generated by the IoT devices. And cloud is a palace. Palace is the place where the king and queen lives. Here, the king is nothing but IoT, queen is nothing but the big data. So just for the easy understanding, I just give this example. Next, we'll slowly discuss why we need the cloud computing. Why this cannot be stored in the traditional database? Why we need this? So cloud computing can be defined as delivering the computing power. When I say computing power, it can be the processing capacity, it can be the networking speed, it can be the storage, it can be the operating system, or it can be the software. So cloud computing is nothing but a platform which provides computing power as a service. And in cloud computing, network plays a very, very important role. Network in the sense, internet plays a very important role. Some of the cloud computing examples are Azure, Google Cloud, and AWS. Again, I will repeat the definition of cloud computing. Cloud computing can be defined as delivering processing capacity, network speed, storage, operating system, software as a service over a network. So whenever you need to have a cloud or whenever you want to use a cloud services, definitely you should have a network connectivity, good network connectivity, because physically this cannot be connected. You need to have a good network connectivity to have the service rather than physically having the computing resources at the customer location. This is what cloud computing is all about. There are three cloud service models, that is infrastructure as a service, platform as a service, software as a service. When I say infrastructure as a service, imagine I run a small business for over decades. And with the revenue generated from a business, I cannot afford to have a server which stores all the 10 years of my data because I'm running a very small business. It gives only very marginal profit. In that case, I cannot afford to buy a server which stores the data in terabytes. So at that time, what I can do is that I can contact a service provider, like cloud service provider, which will provide me storage as a service. Which will provide me storage as a service. What does I do? I pay rent to the cloud service provider to store my business data for the past 10 years. Obviously, if you want to buy a server, it will cost in lakhs. But if I use the cloud services, it is available, I need to pay very minimal amount to store my data. And that will be also helpful because my business is not that good. I'm having only a marginal profit. Under these circumstances, I'm not able to afford to buy a server, but rather I can able to afford to pay a small rent to the cloud services, infrastructure cloud services, such that my data will be stored in the cloud server. That's a good example for this infrastructure as a service. That's why it said it's provision server, storage, and networking resources all come under this infrastructure. The best example for infrastructure as a service is Amazon EC2 and Windows Azure. Next service model in the cloud computing is that platform as a service. Platform as a service, for example, if I have a data and I don't have a proper DBMS, I don't have the software. I'm not able to buy that software since because it's very costly and it's a proprietary software. It's not an open source, imagine. And I badly need that software to do some processing. And that feature is not available in any other open source DBMS, imagine. Then as a poor businessman, what I will do? I can't able to afford. I can't pay this heavy price. Then this cloud service model will come to rescue me as platform as a service. What does it do? This cloud service will have this platform for me, and I have to pay very minimal amount to the service provider to use the particular platform. Rather than buying that particular software for me in dollars, in $1,000, I can pay only $10-20 to the cloud service provider, and I can do that particular, and I can use that particular platform for the particular period of time for which I need it. Of course, if you buy the software, I will be not using that software all day. Whenever I need to do some process, I will do maybe 1 hour per day or 1 week per day. So for that, I need not invest $1,000. I can invest only $20 for a particular period of time. I can use the software to do my process. That's the critical role of platform as a service. And some of the example is Google App Engine, Apache Stardots, operating system. Even operating system can be provided as a platform as a service, and DBMS. Next, what we'll have is software as a service. Again, the software which is needed for the particular business need not be brought by any of the business entrepreneurs. For example, if you want a Microsoft Office, again, that's a proprietary to Microsoft. If you want to buy it for my personal use, again, it costs in dollars. Instead of buying it, what I can do, I can use that software as a service through the cloud platforms. They have a particular period. If you want to use this particular software in the cloud, you have to pay much. That is like to pay and use for a period for which you decide to use. That is called platform as a service. So these are the different models in which the cloud computing service. It has an infrastructure as a service, platform as a service, and software as a service. Next, why we need this cloud computing? What triggers us to go for the cloud computing? So with the increase in the data which is being contributed by the internet as well as by the IoT devices, we need definitely storage as a service. Because as I said, it is now in zettabytes. It is nothing but 10 to the power of 21 bytes. And it is not going to stop here. In down the line 5 years, it will be around 50 zettabytes. And we will not able to keep on buying the infrastructures. It's very, very costly. We will not afford to buy. Any companies cannot afford to buy that. Definitely, we need some service for the storage. Hence, we need to figure out something which will going to give the storage as a service. That is the first point which triggers us to go for the cloud computing. And second point, large and small business scale also functions on data because they also get insights from the data. Even if it's a small business, if we have a reasonable amount of size of data for the past 10 years, I can able to definitely get some business insights, which is going to enhance my business in the future. The small business also thrives on data, and they cannot afford to put large amount of money to store the data or to do some analytics. Again, this prompts the need of the storage, platform as a service, and platform as a service. As I said, not all business can afford a high cost of IT infrastructure, and also we need a backup. Again, we need a storage for that. So to support the small business as well as the large business, we need to have some storage as a service, and that is being provided by the cloud computing in a much cheaper price. That is what the highlight here is that these services being used by the common middleman businessman at a very cheaper cost. Since it is providing as a service, you can able to provide at the minimal cost with high efficiency in storage, with high efficiency in computation, and less maintenance cost. These are the things which make this cloud computing very popular. Why less maintenance cost? Suppose you buy a software. Imagine you buy a software, and there will be frequent update released by the software, which have the new features in it, or it will rectify some of the mistakes in the earlier version. And if you use a software and if you don't update, these features will not be incorporated in a software installed in a desktop or a system or a laptop. And obviously we'll miss the feature which is being added. We need not bother about all these things when you use the software as a service, because the cloud computing platform will take care of these all maintaining things. You need not bother about updates. You need not bother about the errors which is there in the storage server. You need not bother about the security issues in the cloud computing server, in the normal server, because everything will be taken care by the cloud, because we are going to use only the service and the equipment will all be maintained by them. And since because they're service provider, they will be able to give us all kind of sophistication with all kinds of recent update, which all kind of security patches in it, because they will have to upgrade it because they are providing as a service. These are some of the main points which point out the importance and need of cloud computing, and we are in a position to use it now. And for some of the cloud services which you are using without knowing it are Gmail and Hotmail. These, whenever you sign in for Gmail and your email is through, actually we are using it on the cloud services. Our mails are not stored in the mobile. Our mails are stored in the cloud, and whenever it is needed from the storage, cloud storage, it will be transmitted via internet to your mobile. These are the cloud services which are using it unknowingly. So as I said, cloud services in Gmail and Yahoo. While accessing email, our data stored on the cloud server and not on our computer. And the cloud is invisible. That's why we're not really going to appreciate. We're not appreciated because it is invisible. We thought that it is in the mobile or somewhere else. Actually, it is a technology that is invisible. And we really don't bother whether the data or mail or the cloud is really working on HTTP, XML, Ruby. No, we really bother the services which is provided from the cloud is really user friendly, and whether it is achieving what it is intended to do. We need not bother about the functionality, inner working of the cloud. We need to bother about the user interface and the functionality, whether it is doing perfectly its job for which it was built on. And this cloud computing, again, as I said, as I mapped the IoT as a king, big data as a queen, and the palace as a cloud, again, this cloud computing can also be mapped with the traveling system. Okay. There are many cloud providers who take advantage of this to provide pay and use model where customers pay for the specific resource used. So for whatever things you use, you have to pay that one. For example, if you have 10 terabytes of data with you, and if you are going to really buy a server, you will not buy 10 TB because now currently you have 10 TB of data in it, and you're going to buy a server. And definitely you will buy a server much higher than the 10 TB. Imagine that you're buying a server with 30 TB of memory storage. When you buy that and if you store, currently you have only 10 TB. Because considering the future and the scalability of the data, you brought 30 TB of storage, but currently you have only 10 TB of data. The remaining 20 GB at the current point of time will be unutilized, and you have to pay for the 20 GB which you are not using because you are going to buy the storage server for your own personal use. That is, you have to pay for the thing which you are not using. Of course, you brought that 30 TB server considering the scalability. But currently you are not using the 30 TB, you are using only the 10 TB. The remaining 20 TB which you bought, which is not effectively used by you. This will be removed by the cloud computing. Says you have to pay only for the whatever amount you use. If you have 10 TB of data, instead of buying the server, if you contact the cloud service provider, I have to pay only for the 10 TB of the data which I have in my hand. Maybe the next year, if my data increases by 2 TB, then I have to pay only for the 12 TB. I need not pay for 30 TB. That's a real advantage, and you can save a lot many costs if you have these cloud services with you. And these are some of the benefits of cloud computing: lower IT infrastructure and computer cost per user. As I said, improved performance. You have a high performance accuracy if you use the cloud computing. Maintenance issues will be much less. As I said, instant software update. Again, we discussed this point. It improves the compatibility between the operating system. When you build a product on the Windows in the cloud, the same product will work much easily in the Linux. And cloud computing, one of the main advantages is the backup and recovery. Imagine if you have a server and it is your responsibility to take up the backup of the data. If something happens to the server, you cannot able to retrieve the data. But if something stored on the cloud, you need not bother about the backup. There is a service provider who will take all the necessary precautionary measures for your data. They will take a backup, and the recovery mechanism will be there in the service provider. So you need not bother at all. Even if any natural disaster occurs, you need not bother at all about your data. That will be properly, duly taken care by the service providers. And scalability, as I said, today I have 10 TB of data. Suddenly tomorrow I need again 30 TB of data. It can be easily done with the help of scalability in the cloud computing. It can be done at ease and increased data safety. As I said, security patches will be updated now and then until it will provide much secure to our data. These are some of the main important advantages. Next, we're going to see the relationship between the IoT and the cloud. So, like now IoT as a cloud, I can say now we're going to see the relationship between king and the queen. IoT is the king and the cloud, no, king and the palace. Sorry, we're going to see the relationship between IoT and the cloud. IoT is the king and the cloud is a palace. So this comparison between the IoT and the cloud is going to be on 6 different main parameters. The first parameter which you're going to compare is big data. See, Internet of Things actually is a source for the big data. As I said, two things are source for the big data. One is Internet of Things, another is the internet. Second is nothing but this Internet of Things. First comes always internet, second is nothing but this IoT. Second, this cloud computing is act as a way or a means to manage the big data. It's providing a space as a service provider to store the big data. Next parameter is not reachability. So the reachability of any IoT devices is very limited compared to the cloud computing, whereas cloud computing reachability is far spread and wide. If you want to have a really good cloud computing, then it has to have very easy connectivity via the internet. You can connect with any cloud if you have a good internet connection. Storage, of course, in IoT, it is very limited, and we can say it is not even limited. You can say it is a none. And cloud computing storage is unlimited, virtually unlimited. You can keep on adding the storage space capacity and the processor capacity in the cloud computing. So we can say it is never ending virtually towards infinity. And the role of internet in Internet of Things, yes, we need to have the internet to transport the data from the IoT device to the cloud computing. We need to have. And cloud computing, internet plays a very, very crucial role because that is the way by which the by which the user will connect to the clouding. Without internet, user and the cloud cannot be connected. So we need a high amount of internet connectivity and high good connection between the service provider, cloud service provider, and the user. And computing capabilities, of course, we can say limited or none for the Internet of Things, and for cloud computing, virtually unlimited. Components in Internet of Things runs on hardware, whereas in cloud computing runs on virtual machine, which imitate like hardware. This is a comparison between IoT and the cloud, or king and the palace. When I say this IoT is contributing to the big data, and the big data which contains the data from the internet as well as the IoT devices are stored in the cloud, this IoT device somehow has to push the data into the cloud because data generated and it has to store somewhere for the analytics purpose. To store this IoT data to the cloud, we have 10 different cloud IoT platforms. There are many. Now we're going to see around 10 different IoT cloud platforms. The first is Amazon Web Service IoT platform. Second is Microsoft Azure IoT Hub. Third is IBM Watson IoT platform. Fourth is Google Cloud platform. Fifth is Oracle. Sixth is Salesforce. Seven is Bosch. Eight is Cisco IoT Cloud Connect. Ninth is General Electric's Fedrix. Third is SAP. So not in any particular order, I just listed the majorly used IoT cloud platforms. We're going to discuss in brief about each of these IoT cloud platforms. First, Amazon Web Service IoT platform. It is the first IoT cloud computing platform which is developed way back in 2004. And this is very predominantly used IoT platform. Second is Microsoft Azure IoT Hub. So Microsoft, it is taking this IoT very seriously, and they have cloud storage, and they have machine learning and other IoT services for the analytics purpose. And you see, they have their own IoT operating system. Next, we have IBM Watson IoT platform. They are trying to make this cloud service very easily accessible for the layman with very simple steps. So any unknown person also can able to access this cloud services. That's way in that way the platform has been designed, and also you can able to try out the small application to get how this IBM Watson IoT platform works. And you can also store your data for some specific period of time at free of cost. And the pricing, of course, depends on three parameters that reflect how much of data is being exchanged from your IoT device to the platform, IoT platform, and how much data has been analyzed. Based on that, you have to pay for this IBM Watson. And the most important thing is that every month, if you are being keep on subscribing, you will get 100 MB of space, MB free. Next is Google Cloud Platform. Again, the Google, which is a major player in internet, also into the IoT Cloud Platform field, which in itself shows the significance of IoT Cloud Platform. So it's a best to build. This is a Google Cloud Platform is the best place to build all your IoT initiatives, and it has analytics capability, and the machine learning intelligence is also incorporated. It is in this Google Cloud. You will be charged based on your minute, and it is comparatively cheaper compared to Amazon IoT Cloud Platform. And again, like Microsoft, Google also has their own IoT Cloud operating system, and that is based on Android. The fifth one is nothing but Oracle service provider, and they are very focusing on the logistic operations. And the pricing in Oracle is done based on connectivity per device. Next, sixth, we have the Salesforce, and they are very focused on customer relationship management. And their cloud service is being powered by Thunder, with which they are able to attain high speed and real-time decisions can be made in the cloud. So when you want to working on the real-time data, this Salesforce is the best IoT platform to work with. The main problem with the Salesforce is that they are charging a little bit high compared to other IoT cloud platform. They're charging $4,000 per month. Bosch, again, it's a German-based IT company. Again, they are also into this IoT cloud platform, and they are competing now with Amazon. And the main advantage of this Bosch IoT platform is that they are providing higher security and efficiency, and the cloud platform is flexible, and it is based on open source standards and so codes. And the eighth one is Cisco IoT Cloud Connect. And Cisco is a giant in the network, and they have also placed their foot in the IoT cloud platform, and they strongly believe that cloud will have a promising future ahead. Ninth, we have General Electric's Predix. It provides platform as a service as a platform, and they are focused on industrial market, and it offers analytics, and it also offers connectivity, and they have a very cool user interface, and pricing is done based on the usage. The 10th one IoT cloud platform is that SAP, and they have the cloud platform with IoT, big data, machine learning, and artificial intelligence incorporated in it. And pricing is based on the developer, medium business, and enterprise. So if you ask me, there are 10 different things which I discussed. If you ask me which is the best one, which is best for which project, or which one to choose as a normal scenario, and I have really no straightforward answer for this. So there is no best IoT cloud platform, and it is always depend on the business needs. If you say in general, Amazon is the most experienced IoT cloud platform in this field, and but it is quite expensive. You cannot name this as first, and you can't rank among the IoT cloud platform which is discussed. In general, it all depends on your need of the hour. But if you say long time, Amazon has been in the field for reasonable time, and but quite costly is quite high. And if you want to just, you can try with some of the service provider, or usually service provider will offer some trial versions for a particular period of time. And really, if you are confused to go with which IoT cloud platform, you can use that free trial period, and you can really analyze whether it is suiting for your business needs. And still, if you're further confused with to go for which IoT cloud platform, the best thing is that you have to contact some of the development team who has been working in this IoT cloud for quite a period of time, and they will be able to give you insight based on your business needs.